Welcome to Kiruna, and welcome to the Space Master Spacecraft Design Studies. I'm glad to see you all here, and I'm the team leader of Project ASTER on Rexus 30. Yes, and we are attitude stabilized free-falling unit experiment. I'm Rick Dengel, and I'm gonna present a bit about us and about the future of our project and how you potentially can participate. As already said, we're Team Aster. We are a mix of spacecraft design, space masters, and Swedish study students. And we are split over entire Europe because we are by now 2 years old, and all the members basically went to different universities in the Space Master program or have finished their studies. On the left side you can see our work on electronics. In the middle you can see our work on our rocket part. And on the right side you can see, second to the right, you can see our free-falling unit. I'm going to explain everything in a bit. And on the total right side, you can see a review of ours. And on the top left bottom side, of course, you see our mascot, and it's called Spinny. And yes, we had to do stabilize, so we have reaction units. That's why it's called Spinny. On mission overview, we are on a rocket, on a Rexus rocket. We are on this rocket, we checked ourselves from this rocket and then try to fulfill our first objective, our first primary objective, to control our developed free-falling unit, which is ejected, as I said, from the sounding rocket. The second objective is to demonstrate that the ADCS is capable of stabilizing the free-falling unit, and the ADCS is the attitude, determination, and control system. The third objective is to recover the free-falling unit, because if we drop from the rocket, we don't have a big upstream link. We have a bit of iridium data, but that's not very fast, and we would like to get as much data back as possible, so we recover the free-falling unit by retrieving it after landed by a parachute. As you heard before in the name, we are part of the Retrospective Program, where you're going to hear a later presentation about. And it's basically a bilateral agreement between the German Aerospace Center and the Swedish National Space Agency and the European Space Agency, and it's supported by several subsidiaries or partners. And you can either participate in the rocket launch or in the balloon experiment. And we are Rexus, so we're a rocket experiment for university students. Now we come to a bit technical parts of where you can see also a few things. Let's see how sharp and how good that works. We have the RMU, which stands for us for rocket mounted unit. This is the part which is on the rocket and stays on the rocket and basically ejects our free-falling unit from the rocket after the motor burnout, basically. You can see here on the right side a GIF, which basically ejects the free-falling unit. Yeah. Good, no one saw that, so we're gonna make that better. Let's go again. So on the right side you see this GIF, where you see the free-falling unit being ejected.
It's not liking your GIF.
Okay, we try one time more, and then otherwise you have to go for our social media to see it. Good, one more time, and then if not, then not. Yeah, so it basically, here you just see it pushing out, falls out, but the idea is when you're up there, you're in kind of microgravity, and then it just floats out, and then it's the objective because it has some residual spin to stabilize itself. Oops. Here we go. And the free-falling unit, you can see here on the left side, is a so-called flat set setup, where all the wall plates, because our unit consists out of 6 wall plates, they are spread up, but you can assemble them together and lay them flat and connect everything, and you can run everything electronic-wise, but you still see what's happening, because when you close the FPU, the time is over, and you have to be well prepared, otherwise the wheels are going to mess up a few things. On the right side, you see the assembled render of the assembled FFU, but it might be a bit hard to see. It's basically a 150 millimeter cube, so 15 centimeters times 50 centimeters times 15 centimeters. It has on top of it a 30 millimeter high recovery compartment, where the parachute and the streamer for deployment and recovery are accommodated. It's about 3 kilograms heavy, and we have a payload volume of 300 cubic centimeters, which is about our usual Red Bull Coca-Cola can, which you can put basically a space in there, and in there you can accommodate future experiments. So we're developing this platform for to stabilize a unit, and we have then in free fall we can do any science experiments what we want. Reaction wheels are the most important part of the system. Without this, we can't basically stabilize anything. This is a short overview of it. We have a motor, we have some bearings, a bracket which attaches it to the wall plates, and around is then the rotor, which has a quite high inertia to be able to stabilize everything. And on the right side, you see also a GIF again, where the motors run. You see them a bit running, and you see also the electronics, and you see it's actually quite tight in there. And the remaining room is meant to be free because we want to have a payload on there, in the future at least. You see also here the attitude control. You see it standing still. When it basically decelerates the wheel or accelerates it, it spins. And when you go back to the same speed where you were in the beginning at, it basically stops again. And this we can do hopefully soon in 3 axis, and it's currently being tuned in 1 axis, as you can see here. Yes. To get our data, we have during the rocket uplink, while we're on the rocket, we get data. So we know until we eject from the rocket, we get data back, and later we get data via Iridium. So we know, hopefully, at most of the time during our experiment, we get some data back, and we see that our experiment works well. Recovery, you see here. I don't know who knows it yet. It's the new Schüttegarten, that's how we call it, because there was an old building before. There's a new student accommodation. Has also bigger and nicer apartments, so it's newer. And we dropped it from the upper floor. You might not see there, it's Andy standing there, you don't see him. Really, he's dropping the parachute, and we're doing here a drop test for to deploy it, and basically this altitude is enough to directly deploy it, but we're also gonna do soon a drop test from a plane. Our current status is, I guess since a year. Yeah, the status is also not a lot. I can also just leave the statuses anyway, so the same.
The status is the same as the status of process.
Yeah, so I can also, that part I can quickly explain when you have a bit of time. So we have different reviews over the timeline. We have passed the most of them, so preliminary design, critical design, when basically everything is frozen and finished. And then we have integration progress review, which was in summer, or in the end of summer of 2020. And since then, since Retrospective is delayed due to the COVID situation, we're waiting here for the experiment acceptance review. So we have time to improve a lot. No, don't worry. So this is our current status. And yes, so we are currently at this waiting period right here. And this is why we are waiting, and we have also a few months left to our hopefully final EIR, which will be in November. And with this, we have quite come a far way. But as you see, we have been 2 years. A lot of people have split over Europe, and we are now at the time where we need to finish the last things. So what we need now is we need 1 or 2 people, which would be willing to apply very quickly to us. I'm gonna explain this in a bit, which can also help us on a bit of technical side, support us on the side. You will not be directly alone in the beginning because it's quite complex. So you will get all the support, the experiments from our side, which will also then help you after November, because then it's more or less over. The latest, you will be able to join another team from here. So you have to get a bit more experience, and you can join us in the beginning for 2 months, 3 months actively. And then you can join another experiment and apply all the experiments which you have from us. So we can ultimately make it also to liftoff. How to apply? I guess this will come later again, but just here the overview. Eligible are only students who are in Kiruna. Because of the situation, we have 16 team members, but roughly 10 are not here, so we are like 6 people. And we are in the end of our thesis. I just finished my internship. Björn is also in the end. So Björn is in the back here, who doesn't know him. He is our lead engineer, and he's one of those 2 people who are most here, and you can ask us anything. We know basically the entire experiment. And so you need to kind of be here to be able to work on the hardware. I think that makes sense. Then you need to fill in the Google Sheet, which are going to be distributed later. And the application deadline is on the 10th of September, but we started recruiting interviews immediately. So when you send it in, we will hopefully see the email, or as soon as we see it, we will answer you, invite you to an interview, or similar, and then go from there. And the announcement of the results for all applicants are simultaneously, so around the same time, latest on the 17th of September, so the Friday afterwards, so in 2 weeks, which is the latest date, because when we have on the 10th of September, we have one application or two, we do an interview on Monday. When we're done, we can send out the results, so you don't have to wait that long. But the 17th is the latest result date. So we're searching therefore 1-2 people who can support us on that side, and they know basically everything in the end, or should know a lot about the Retrospective Program, which we can start also, or other projects here. Thank you for your attention. Again, glad to see you all here. Follow our social media, which is biggest here in Kiruna. Don't hesitate to follow us. We have few weekly posts and whatsoever. You can see all the videos. If you didn't see them properly, you can see them there. And you can also contact us there, ask questions, whatever you want. And you, of course, feel free to ask questions now. Thank you.